In this episode, we are talking about a part that seems simple at first glance, but often it's going to trip up even the most experienced engineers, and that is the common mode choke. Now, if you've ever opened a datasheet, you maybe picked the part with the biggest inductance number, and then you called it a day. Well, you're not alone. In fact, you might now be heading for some trouble. So in this episode, we're going to be taking a look at two of the most common mistakes that engineers make when selecting power line common mode chokes. The first is choosing a choke based on inductance instead of impedance, and the second is overlooking how core material and geometry affect performance. You're listening to Würth Elektronik's What's Up Radio podcast, where we're talking about what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronik technical specialists. We're going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and today, the basics and common pitfalls of the common mode choke. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast. So let's start with the big one, the misconception of inductance versus impedance. Now, most designers default to inductance when they're choosing a common mode choke. It's right there on page 1 of the data sheet, a single clean number measured at a standard frequency, usually 100 kilohertz or 1 megahertz. But inductance does not tell you how well a choke suppresses EMI. At low test frequencies, the ferrite looks linear and the parasitics are quiet. Now, the EMI that you are trying to block usually lives up in the tens of megahertz, and at those frequencies, the winding capacitance and the core losses take over. Two parts with identical inductance can have completely different impedance curves and very different attenuation. So think of inductance as a preview, and impedance is the full movie. So instead of asking, what's the inductance, the better question is, what's the impedance at my noise frequency? That's why Würth Elektroniks publishes full impedance curves, and that's why we built the Red Expert tool. Selecting by impedance lets you match the choke's behavior to your actual noise spectrum, which gives you a much clearer picture than the inductance figure on the datasheet. So next, let's talk about core material, because it is often the deciding factor in whether your choke delivers the suppression that you need. The most common ferrite materials and power line common mode chokes, or CMCs, are manganese zinc, nickel zinc, and nanocrystalline alloys. Now, manganese zinc has high permeability, and it works well for those lower frequency noise, typically below 10 megahertz. Losses increase at higher frequencies, so it is often used in mains filters. Nickel zinc has lower permeability and higher resistivity, which places its impedance peak a little bit higher, often in the 30 to 100 megahertz range. It's well suited for switching converters and high-speed noise. And finally, nanocrystalline offers very high saturation flux density and low losses across a wide band. It's more expensive on a one-to-one basis, but often you can use a smaller size for the same performance, which could offset that cost. Now, choosing the wrong core material shifts the impedance peak away from where your noise actually is. So the key here is to choose the material that delivers the right curve shape for your application. Common mode choke construction also influences performance, especially in power applications. You don't need to know every detail, but a basic understanding definitely helps. Power chokes always use sectional windings. Bifiller is for data and signal lines only, where tight coupling and very low leakage matter. Sectional windings separate the coils for safety spacing and introduce some leakage inductance, which helps with differential mode noise. Core shape plays a role too, so toroids such as the MyWE CMB series provide very tight coupling, low stray flux, and low winding capacitance. Their impedance curves are predictable and efficient, and the natural leakage is whatever the geometry provides. Frame cores, like the WE LPCC family, gives your design more flexibility. Their open structure naturally provides creepage and clearance, and some versions include a small gap in the center leg that sets differential inductance intentionally. So that makes frame cores useful when you want controlled leakage for additional differential mode filtering. They also allow more creative safety spacing in custom designs, even though the catalog versions maintain standard voltage ratings. These differences do shift parasitic parameters, but customers usually do not need to optimize at that level. So what matters most is choosing the choke whose impedance peak lines up with the frequency of your noise. So a common mode choke works when two windings carry equal and opposite current, which cancels the magnetic flux in the core. Saturation only becomes a concern when that balance is disturbed. And this can happen when a DC component rides on the line, when routing or grounding causes one of the windings to carry more current than the other, or when common mode current flows through capacitive paths to the ground. So most power line chokes, especially the tightly coupled WE-CMB style parts, are very difficult to saturate under normal conditions. When saturation does occur, it almost always comes from current imbalance rather than the total current level. Core shape can influence how the imbalance shows up. Toroids handle small imbalances well because of their strong coupling, while the frame cores can show imbalance effects earlier if the magnetic path is more open or if a built-in gap is used to set differential inductance. The rated current on the datasheet is a thermal rating. It indicates how much continuous current the choke can handle without exceeding its temperature rise limit. It is not a magnetic saturation threshold. Staying within the rated current ensures long-term reliability, even if saturation is unlikely. So here is a pretty simple standard workflow for selecting a power line common mode choke. First, identify your noise. Use pre-compliance data or a near-field probe to find where your common noise peaks. Next, take the easy route. Use Red Expert to match the impedance peak to your noise band. This matters far more than inductance. Third, check the rated current. This is a thermal limit, so make sure that the choke will not run too hot in your design. The next step here is verify voltage and safety ratings. So use that datasheet to confirm working voltage, isolation, and spacing. And finally, the fifth step, choose core material and geometry. The material sets the impedance shape, and the toroid or frame structure slightly shifts parasitics. All power chokes use sectional windings, so focus on impedance and safety. Follow these steps and you'll avoid the most common pitfalls in CMC selection. So to recap, a few rules to follow. Do not select by inductance. Also, choose based on impedance across frequency. Next, match the core material and the geometry to your noise and your safety requirements. And then finally, always verify performance under real operating conditions. Thank you for tuning in today. Now, we know that while some streaming platforms are making that switch to video format, there are still plenty of listeners tuning in through audio only. So if you'd like to learn more, head over to our website where you can download the datasheets and additional technical materials. You can also find all the images, demonstrations, and diagrams we talked about today in our YouTube video. If you're interested in taking those next steps, visit our website, specifically our Red Expert design tool and calculator, where you can actually compare impedance curves based on your parameters. Visit www.we-online.com/redexpert, and when you're ready to get hands-on, selecting and ordering chokes or other components is easy. Just order directly from Red Expert or reach out to your regional Würth Elektronik contact, chat with a live team at Würth Elektronik Online, or order directly through the MyWE customer portal. You're listening to Würth Elektronik's What's Up Radio podcast, where we're seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Elektronik technical specialists who are going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Elektronik's What's Up podcast.